Right, so this 12.4, the very last chapter of pure maths about vectors, which is essentially, funny thing is, it's about mechanics. Thing is, with this chapter, you're not going to see it a lot in pure maths. I don't think it's ever come up in pure maths, mainly because it comes to mechanics. I don't know why they include this part, but I thought they'd probably try to link it between mechanics and pure maths. But the maths in here is either too simple for mechanics or pure maths has too much content just for mechanics. There's no space for this basically in a pure paper, really. So I wouldn't pay too much attention to this one. However, there are some fundamentals which is going to help you in mechanics as well. For example, in here you've got three forces in vectors. Does anyone remember how to find the resulting force when the forces are given in vectors? Just add them together. Okay, so part A, to find the resulting force, R equal F1 plus F2 plus F3. Now, this is normally not achievable, but only it's achievable in vectors. Okay, so if I ask you to find a resultant force, normally you can't do that. You can't add them together. It doesn't work that way. Because in mechanics, we've learned to find the resultant force, you will have to consider X and Y separately and use F equals MA. But because of vectors, you are allowed to do that. You just add them all up. Okay. So add them all up. So F1 is, so R equals, F1 is 2 minus 1, 2. I like to put in column vector form because it's much easier to do calculation. Minus 1, 3 minus 3 plus F3, 4 minus 3 minus 2. So the 4, which is add up row by row, 2 minus 1 plus 4. Well, hopefully you will do this in a calculator because you don't want to make any silly mistakes. Minus 3. Okay, so that's Newton, and that's it. That's the resulting force. Unless it asks you to find magnitude, you don't have to find the magnitude of it. I mean, yeah, so that we can leave it in vectors. Part B, find the acceleration of the particle. Give your answer in the form of Pi plus Qj plus Rk. So how do we find acceleration from force? One and the only one, F equals ma. F stands for resultant force, so we're going to use the result in part A to help us to do that. Yep, just checking if I'm showing. F is 5 minus 1, 3, so 5 minus 1 minus 3 equals the mass, which is 0.5 A. So if you divide 0.5 to the left-hand side, you essentially divide every single term in a vector by 0.5. So divide by 0.5 is the same as multiply by 2. So A is 10 minus 2 minus 6 meter per second squared. This annoying question want us to put in IDK form, so we have to agree and just replace it. 10I minus 2J minus 6K meter per second squared. Part C. Part C. Find the magnitude. To find the magnitude, well, that's simple. Because magnitude, we square each component, add them up and square root Pythagoras. So 10 squared plus 2 squared plus 6 squared. I'll just put a calculator. 11.8 meter per second squared. Branch 3SF. Part D. So I'm going quite fast in here because these are not difficult maths in here. We've done much harder things in mechanics. It's like teasing us. Part D. Given that the particle starts at rest, find the distance traveled in the first 6 seconds. What comes to your mind first? First thing first. What does come to mind? Subart. Time. Distance. Subart. Okay. Put it in here. Subart. So Subart. To find distance, that means F must be unknown. What else do we know? Time is 6. Acceleration is 11.8 from part C. Start at rest. Good job. That's the hidden information. Got more than what we need, to be honest. So therefore, we choose the one that we can use it. Maybe S equals UT plus half AT squared. Yeah. So S equals to 0t, so half times 11.8 times 6 squared. I got 213 meters. And that's why you won't see the exam. It's just to I would say like maybe a nursery level of maths in here compared to what we've done. Next one, okay, a little bit more interesting. In this question, I and j are the unit vectors due east and north, and k is the unit vector vertically upwards. So we talk about a plane in here. So what it means is if you think about a plane, you're flying on a plane in here. How do you draw a plane? A plane has a slightly pointy tip. Yeah, and this is you flying on a plane. Oh, you don't see the legs. Just the head. Just a head. So it's you. Okay, so it's flying. How do I make some animation flying? Yeah. Right. So what we're trying to say here is due north and due east means if the plane is moving, let's say that way, that means this. Say that will be your I. Backwards will be your J, and then up and down your magnitude. What's the word again? What's the height called again? The amplitude, is it altitude? That's what English. Altitude, thank you. The altitude will basically be your K. Altitude will be your K, thank you. Altitude is your K value. Okay, so that's what we're trying to do here. Right, so aeroplane of mass 100 kilogram is initially in level 5 flight. The forces of thrust T, lift L, and combination of wind and air resistance F is all listed in here. Take G as 9.8 meters per second squared. Find the magnitude of acceleration of the aeroplane. Part A. Find acceleration. We'll use F equals ma. So F in here is not the same F as the question because this is the resulting force. I don't expect you to draw the same masterpiece as I do, but in here, what we're lacking of in here, what do we need? What force do we need to put in this diagram? Now we've got 3 forces, but we're also missing a 1,200. This is the hidden information you must know. Because of mass, there'll be mg pointing right there. Now you think about this mg in terms of ij and k. Which direction is this weight acting on K? Okay, because the mass or the weight pointing downwards, think about altitude, so think of sorry, that's K. So that means the resulting force, I'm just going to put resulting force in here. Resulting force equal P plus L plus F plus the weight. Okay. So that's right, put it there. So T is 2,800. I, so let's put it in column vector. 2,800. J is minus 1,800. K is 300. L is 11,000 K. So how do we present L as a column vector? So 11,000 K. 0, 0, 11,000. Okay. Plus F minus 900 on I, 500 on J, and 0 on K. Plus the weight. Now the weight is mg, so it's on K, so 0, 0, 1,200 times 9.8, but because it's pointing downwards, it's negative. This is mg, 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 negative because downwards. So hopefully it does make sense in here. Well, let's just bracket. No. So what we're doing here is just a resulting force. Okay, we've not done anything about acceleration yet. So we're going to simplify everything in here, put in one big bracket. You can use a calculator, simplify it. You should get 1,900 minus 1,300 and minus 460. That's the resultant force. Then it's time to use F equals MA. So your F is your 1,900 minus 1,300 minus 460 equals the mass for 1,200 A. Divide everything by 1,200. A will equal to 19/12 minus 13/12 and minus 23/60. I'll read the question again, see if I've answered the question. That's a good habit. Always sort of, if you're unsure, always read the question before you move on to the next one, just to make sure you've answered the question, especially when they ask you to find the coordinates, that kind of thing. Round your answer to SF 3 decimal places. By reading the question again, you can refine your answer and don't make silly mistakes like that. Find the magnitude. Well, I've got acceleration in a vector. Find the magnitude, that's easy. 19/12 squared plus 13/12 squared plus 23/60 squared, which is a funny number we've seen a lot, 1.96 meter per second squared. In mechanics, but we'll see this number quite a lot, 1.96. Right. Questions? Right. Part B. Determine whether the aeroplane is ascending or descending, and find the size of obtuse angle. It says its acceleration makes with the vector k. So two questions in here. First one is ascending or descending. The second one is the angle. First of all, ascending or descending. Anyone would like to make a guess? Ascending or descending? What determines if it's ascending or descending? Up and downward forces. So the overall forces on the up and down, which the k, the altitude, is minus 460. That means it is descending. Okay, so part B. Aeroplane is descending because the resultant force in k direction is negative. So if you want to, if you don't understand what it means, you can use a pencil again to link it back to this force in here, both in here, just to show. Okay, so it's descending because the resultant force in k is negative. Right. So and then also find the angle. You have learned how to find the angle. The formula is cos theta k equal k over magnitude of A. This is from 12 point something, 12.2, I think. So cos theta k equals to the k value is, oh, by the way, it should be actually, it will be, we're measuring against the acceleration, so it should be acceleration. Oops. Yeah, my bad in here. Of course. My mistake. As a human, you always make mistakes. It's the acceleration that matters the more, because yes, it's not the force. No, it's not a force. It's not a force. Yeah, it's not a force. The acceleration. So anyway, the K value is negative 23/60 over the magnitude of A, which is 1.96. So the theta of K is under 1.3 degrees. Of course, I will do anti-climax in the last bit of the pure maths. Wasn't meant to be, but anyway, here we are. A bit dramatic, but here we go. So that's the end. Okay, that's the end of the pure maths. And that's the end, also at the end of the lesson.